Our next video here on how to write the equation of a line when given a point and a line that is parallel to it. So let's get started. Try to get this thing in under 8 minutes or so. So we're trying to write the equation of a line that goes through this point and is parallel to this line. So first things first, we need to know what it means for two lines to be parallel. And that really is a sort of study of slopes. If we talk about two lines that are parallel, really what we're saying mathematically is that they have slopes that are the same. So if this slope is 7, this slope is going to be 7. Since the parallel lines never intersect, they have to be sort of rising and running at the same rate. So the slope of our new line, our parallel slope, when I write parallel, I'll just use those two parallel lines notation like that. So our parallel slope is going to be exactly the same as the one that's given. And it's going through this point right here. So what I'm going to do is write y equals mx plus b using my new slope right here. And then I'm simply just going to enter in the y and the x as I see them above. So -4 is equal to -7 plus b, and b is 3. If you wanted to, and maybe I'll go through this quickly, if you wanted to, you can use the point slope formula. The point slope formula is a useful thing. I don't tend to use it so much in my class because we can do everything we need to do with y equals mx plus b. But here we have a slope and a point, so we can use the point slope formula. So it's y minus the y value that's given is equal to m, which is 7, times x minus the x value that's given. Simplify, and we should get the same thing. Let's see. Distribute 7x plus 7 and subtract 4. And turns out that it is the same, right? Over here we would take 7 and put it right here, x, and we would take our b and put it right here. Alright, I'm getting that from our y equals mx plus b form, in our slope-intercept form. Alright, so my claim is that this line is parallel to this line and it goes through this point. And I think a really nice way to check this would be to graph it. So I'm going to go to my graphing calculator and I'm going to type in both of them. I'll type in 7x plus 1, and I'll type in the other one 7x plus 3. And let's graph them. A little tough to see there, so let's zoom in a little bit. Let's go to zoom 2, press enter again, and now we can see that these two lines definitely are parallel. And I'll kind of make this a little bit bigger so we can see. I have one graphing as bold, the one that crosses at 3. Maybe I'll even zoom in a little bit more. Zoom in one more time, see what this looks like. Yeah, it's pretty good. So now we can see that these two lines are parallel. Alright, we want to see if the point -1, -4 is actually on this graph down here, 7x plus 3. So in our calculators, y sub 2 was 7x plus 3. So we go over to our table and we say, alright, when x is -1, y sub 1 gives us -6, but we want to know about y sub 2. Y sub 2 is the one that we just found, 7x plus 3. And sure enough, -1, -4 exists on that graph. And we can also check it without the calculator, of course. So let's just plug it in. -4 is equal to 7 times -1 plus 3. -7 plus 3. Yeah, -4 equals -4. That looks good to me. And we know they're parallel because they both have the same slopes. Number 2. So here we have a slope of -4/5. So my new slope, my parallel slope, is going to be the same thing. And when the negative is out in front, you can either put it in the top or the bottom, just not both. I tend to always put my negative in the numerator for some reason. So we from here, just want to go through y equals mx plus b. Our m we just said is negative 4/5. Our x is given from this point up here, and our y from that point up here. So 1 is equal to negative 4/5 times negative 5 plus b. Negative 4/5 times negative 5 is just positive 4. Right, the 5's cancel, and we have negative negative, so that makes it a positive 4. So our b is negative 3. So we bring it all together, negative 4/5 x minus 3. Negative 4/5 x minus 3. And again, we can check that. Right, just make sure that they have the same slopes. They're parallel to each other. They have the same slopes. That's good. And also check to make sure that this point actually fits on this graph. The left side should equal the right. Let's see. 5's cancel. We get positive 4 minus 3. 1 equals 1. That's a good deal. So there you go. 2 quick examples on how to write the equation of a line when given a point and a line that's parallel to it. In the next video, we're going to talk about perpendicular. We'll do the same type of video, just instead of parallel, we'll do perpendicular this time. It's a little bit trickier. So thanks for watching, and I'll see you in the next one.